Hello friends, in this video we will solve this cantilever beam problem which carries 2 point loads, uniformly distributed load and also a couple. We will find the shear force and bending moment values and also the shear force and bending moment diagrams. The usual sign conventions are given here. Now let us solve the problem. As we know from our previous videos, we have to divide into segments. How many segments we may have to divide this beam? It is divided into 2 segments between loads. First between CB and between AC. Now let us find the shear force. First between CB. So the definition of shear force, you have to sum all the forces either right side or left side. So I am taking a section here. To the right, I have only one external force, right? So Vx equal to right side downward is positive, so 8 kilonewton, it's a constant. So at VB we are getting 8 kilonewton. Between CB it is constant, and we should not add the couple with the force, right? So now the bending moment, parallelly we will find for CB segment mx. How many moments are there? 40 kilonewton meter, it's a couple, and then the 8 kilonewton about the section will produce a moment. So the force into perpendicular distance, that is going to be clockwise. That's going to be clockwise. So clockwise is negative minus 40 minus 8 into x. It is a linear expression. At x equal to 0, we are at B, MB equal to, substitute for 0, this term will go, 40 will remain. So 40 will be there at B, minus 40 kilonewton meter. At x equal to 4 meter, I am at C, so MC equal to, substitute for 32, so minus 72 kilonewton meter. So for first segment, the shear force and bending moment values have been obtained. Now we will move on to the second segment. I will delete this. Okay, I'll pass a section. X equal to 4 meter, x equal to 10 meter. So that is the segment, right? Now I have passed a section. Now I will add all the forces to the right. So I have one force, second force, and then this portion of UDL you have to change into point load. So what is this distance? This distance is x minus 4, x minus 4, right? So x minus 4, it will act, the point load if I am changing this UDL into a point load, 2 is the W, so 2 into x minus 4 is the force. So between AC, Vx equal to 8 kilonewton plus 10 kilonewton plus 2 into x minus 4. So it is a linear expression. So at x equal to 4 meter, right, this term will go. So Vc is 18 kilonewton. At x equal to 10 meter, I am at A, substitute 10 here, 6 into 2, 12, 22, 30 kilonewton. So we have obtained all the values, right, at the segments. Now, even without doing all this, directly we can get the values. At B 8 kilonewton, at C 8 plus 10, so we are getting 18. If I am here, my section is here at A, and look at all other forces, the entire UDL will be converted into a point load. So 6 into 2 is 12, that will be acting at mid. So 12 plus 10 plus 8, 30 at A. It is going to be 30. So very directly you can very easily obtain these values. But this constant, this linear, these variations, the expression, how the shear force diagram is going to be, how the bending moment diagram is going to be, that will be obtained when we understand this way. Right. Now the bending moment diagram, AC, Mx, right, 3 forces and 1 moment are there. So these 3 forces about this section will produce moments, and the couple has to be added. So minus 40 minus 8 into perpendicular distance is x, minus 10 into, what is the perpendicular distance for 10? This distance, it is x minus 4, and for 2 into x minus 4, what is the perpendicular distance? The perpendicular distance is shown here, and it is half of x minus 4. So this distance is x minus, I'll write it here, x minus 4 by 2 is the perpendicular distance. So minus 2 into x minus 4 is the shear, is the force, and the perpendicular distance is x minus 4 by 2. This 2 goes off, and this expression is going to be parabolic. Right? Now I apply boundary condition, x equal to 4 meter. Already we have found for bending moment MC. Even if you substitute 4, this term will go, this term will go, these 2 terms remains, and substitute 4 and we will get minus 70 kilonewton meter. At x equal to 10 meter, I am at A, substitute for x, 36, 6 into 10, 60, 10 into 80, 40, 80, 60 and 36. It's going to be minus 116 kilonewton meter. So we have obtained all the shear forces and bending moment values. Now I am going to draw the shear force bending moment diagrams. A, B, perhaps C. So when we have a point load, the shear force will have a step. The step is 8, and between CB it is constant. The value is 8 kilonewton, and then there's a step that is 10. The value is 10, and then between AC the variation is going to be linear. You can use dV by dx equal to minus W. So when we have the slope 0, there's no W that is acting in the beam, then the slope is 0. Now we have a slope, constant slope, so it is going to be linear, right? It's linear, straight line. The value here is 10 kilonewton, and the value here is 30 kilonewton. Right? Now I will draw the bending moment diagram. Same AC B. At B we have a value. So when you have a couple in the beam, the bending moment diagram will have a step. Okay, so 40, at B we have 40, so I draw that, and between CB the expression is linear. The value is going to be 72 kilonewton meter, and when you have constant in shear force, the bending moment slope is constant, so it's going to be linear, straight line. Then between AC, right, there is a jump in the value, so slope is at the junction itself, slope is changing, and then the value is increasing. The slope will change in the bending moment diagram using this expression. So here, right, it's a parabolic curve. The value here is 216 kilonewton meter minus. I hope you would have understood how to get the values and the shear force and bending moment diagrams. If you have any doubt, you can contact me through the email or the mobile number which are given in the description. Leave a comment in the comment box if you wish to. Thank you.